Hey there, Ravens. Today we're talking about the ideal gas law. Alright, so let's start by thinking back to stoichiometry. When we were in our stoichiometry unit, what was the value that we used to convert moles into liters? Okay, for volume, we said that 1 mole of any kind of substance was equal to 22.4 liters of that substance as long as it was a gas at STP. Well, what exactly does being a gas at STP have to do with anything? Okay. Well, we can only make this claim under the conditions of STP. So STP standard for standard temperature and pressure. And I said don't worry about what it is, that we'll get to it when we get to gases. Well, here we are in gas laws and we're studying gases, so it's time to learn. Okay, standard temperature is 0 degrees Celsius, or if we converted it to kelvins, that would be 273 kelvins. That's a 3. Okay? For standard temperature. Standard pressure is then equal to 1 atmosphere. And these are values that you need to memorize. So anytime you see reference to STP, you do know the temperature and you do know the pressure if you're told that this is occurring at STP. Okay, so let's get to the law itself. Alright, so if we take the 3 main laws, Boyle's law, Charles' law, and Avogadro's law, and we set them all equal to volume, you'll see that it's a constant, okay, which is the K, the B, and the A, and related to pressure, temperature, and the number of moles. If we put all these things together, we end up with V is equal to R, the ideal gas constant, which takes into account all the 3 constants mentioned above, multiplied by T times N divided by P. If we rearrange it, we get the ideal gas law. Pivnert, PV equals nRT. R is a constant, and it is really, 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 really important. Did I say really enough? Really, one more time. Really, really, really important that you notice the units, okay? This R value will always be given to you, but if you're going to use it, you have to know that volume, so when you're over here for volume, it must be in liters. If it's not given to you in liters, you will have to convert it into liters. Pressure is in ATMs. So all your units for pressure must get converted to ATM if it's not already there. N is easy because that's always the moles. But if you're given grams, you must convert to moles. And then temperature must be in kelvins, and that's no different than anything else with the gas laws. Okay, that must be Kelvin. All right, next slide. So what exactly is an ideal gas? It's a hypothetical gas that exactly obeys the ideal gas law. Okay, and R is the constant, and here are those units again that get used with those constants. Now, gases in real life, real gases, are not ideal gases, but in beginning chemistry, we focus on understanding ideal gases and ignoring the fact that the gas particles themselves have volume, which affects this ideal gas law. You'll learn about that when you take college chem or an AP chem course. Okay, and how is R derived? Okay, so if you rearrange the ideal gas equation to solve for R, and you input all the conditions under STP, I have to show it to you. I thought it was clicked on here, but it's not. All right, so pulling up the pen. Okay, if we rearrange for R, R is then going to be equal to, and again, we're working with Pivnert, so PV equals NRT. T. If we want to get R by itself, we're going to end up taking PV and dividing it by N and T. Okay? Well, pressure is 1 atmosphere. Volume of a gas at STP is 22.4 liters, and it doesn't matter what the gas is. And N, number of moles, we're talking about 1 mole. Okay, and our temperature is going to be 273 kelvins. And what do we get for R? When you divide the 22.4 by 273, you are going to come out with 0.0821 liter atmospheres over mole Kelvin. And yes, I wrote atmospheres first, but that's okay. I just always remember it as liter atmospheres mole Kelvin. Okay, and that is what R equals. That's where R comes from. So R is always this value for the ideal, and then whatever your current pressure may be, your volume may be, your number of moles, and your T, you put those in whatever the question tells you. Okay? All right, so next up is going to be, we have 2 practice problems that we're going to do, and I'm going to do those in a separate video, so if all you wanted to do is watch the practice videos, you could do that. All right, so I will see you again in just a few moments. Bye-bye.